Okay, now, so last time we looked at one type of improper integrals, and remember that was an improper integral that involved infinity. So we looked at this type of improper integral, maybe 1 over x squared dx. And this is one that it has in the bounds infinity. Okay, so we were letting x go to infinity. And one of the things that we noticed was we came up with this idea that if you compare a couple of integrals, maybe these two, and we just change the integrand a little bit, one of the things we noticed is that this first integral, 1 over x squared, that's going to converge, and the 1 over x to the 1/2 is not going to converge. So that's just one of the things that we want to remember that we looked at last time. And remember how we set these up. What we do is we just change it to a limit. So I might say, well, b goes to infinity, and then I have 1 to b, and then 1 over x squared dx. Okay? And we do the other one that same way. But here's the thing. We found that this one converges while this one doesn't. Now, to help us see why that might be the case, you might want to just look at how these functions behave as x goes to infinity. In other words, if you consider just looking at some various values for x, and here I've got 1 over x squared, and maybe I'll do this. I'll put 1, 10, 100, 1,000, and so forth. And if you look at this, you've got 1 over 1. Well, that's 1 over 10 squared. Well, that's 0.01, right? And then 1 over 100 squared. So you see that you're getting some big numbers fast on the bottom, right? So what's happening is the bottom here is just blowing up and the top is just fixed. So you can see with this function, this is going to 0 very quickly. Extremely quickly, right? Okay. Now, on the other one, and that's because you're raising that to, something bigger than 1. So you're raising it to a higher power. Now, if you look on the other hand, if you look on the other hand at maybe this one, x over 1 over x to the 1/2, you're going to find that it doesn't go to 0 quite as quickly. This first one goes to 0 very quickly. So this is 1. And then instead of 10, let's do 9, right? 1 over the square root of 9 is 1/3. And instead of 100, I can go ahead and do 100, can't I? 1 over the square root of 100 is 1/10, and so forth. But you see what's happening. Here we had 1 over 100 squared. Here we had 1 over 10. So yeah, this 1 over x to the 1/2 is going to 0, but it's going there very slowly. So that kind of gives you insight into why is it that when the exponent is less than 1, we get divergence, whereas when it's greater than 1, we get convergence. Now, what I want to do is I want to look at the next step to this. I want to look at the next type of improper integral, and in particular, I want to look at this integral. I want to look at, let me do this. Let me go 0 to 1 of 1 over x squared. Okay. So I'm taking that 1 over x squared, and this time I'm integrating not to infinity. I'm not going to go from 1 to infinity. I'm going from 0 to 1. Now, this is an improper integral because right here at this point, 0, you get something that's undefined. There's a vertical asymptote there at 0. So really, we can't plug in a 0. In other words, we couldn't evaluate this thing. So here's what we're going to do. We're going to rewrite this in a similar fashion the way we did earlier. And I'm going to do this. I'm going to say a is going to go to 0 from the right. Okay? Because remember, what we're doing is we're looking at an interval here. Here's our graph. And we're looking at this interval from 0 to 1. Now, So we're going to evaluate, if we're talking about a limit, it's going to be coming from the right. It's not just the limit overall. We're looking at the interval on this limit from 0 to 1. Well, if you're anywhere in that interval and you want to go to 0, you're going to come from the right. There's no coming from the left. So this is going to be a one-sided limit, and it's going to go from a to 1, like that. And now we evaluate it like usual. So I would write my limit. A goes to 0. And now the antiderivative is negative 1 over x. Is that right? Negative 1 over x? And I'm going from a to 1. Now I just plug in. So here we go. I've got negative 1 over 1 minus the limit as a goes to 0 from the right of negative 1 over a. Now, this first part, well, that's easy for us to evaluate. But the second part, right? As a goes to 0, so a is getting smaller and smaller and smaller. You've got 1 over this increasingly small number. So this is going to infinity. This is blowing up. So we say, okay, this thing diverges. Okay? Now, the very mechanism that made 1 over x squared go to 0 very quickly when x goes to infinity is making it blow up very quickly when x gets closer to 0. Okay? So if you go to infinity, this thing goes to 0 very quickly. But if you go to 0, this thing gets very big very quickly. Okay? So something different happens. This integral converges from 1 to infinity, but from 0 to 1, it diverges. Okay. Any questions about that? Now, likewise, we could look at the other integral we compared this to, and we could go, okay, from 0 to 1 of 1 over x to the 1/2. And notice, now we have p is less than 1. The power up there is less than 1. We still work this the same way. We've got the limit as a goes to 0 from the right, and we've got a to 1, and then this is negative 1/2. And if we go ahead and integrate this now, or get the antiderivative, what would we have? We would have the limit as a goes to 0, and that's going to be, okay, so we got, well, let's just go ahead and work it out. Okay. And we're going from a to 1. So it looks like what we're going to get is we're going to get the limit as a goes to 0, and this is going to be 1 over 1/2, which is 2, x to the 1/2. Okay. Now, if we put in the 1, we get 2 minus the limit as a goes to 0 of 2a to the 1/2, which that's just going to be 0, right? So it looks like this whole thing is just going to be 2, right? Everybody see that? So this thing we learned yesterday about the integral with 1 over x to the p, that has one result when x is going to infinity, but it has the opposite when x is going toward an asymptote. Okay, any questions about that?
What did you do right there
At the very beginning?
Well, yeah, whenever you turned the integral just into the limit.
What I did from here to here is just simply, I took out the 0 because that 0 is where the integral is undefined. There's a vertical asymptote there. And what I did was I said, well, I'm going to replace that with an a and just see what happens when a goes to 0.
What would you do from there to bottom to the next line?
From there to here? Well, from here, on this step right here, what I was doing was I was finding the antiderivative. I was going 1 over negative 1/2 plus 1, x to the negative 1/2 plus 1. Okay. So I was just getting the antiderivative. Okay, any other questions about that? Okay, so this is how we deal with situations where in the interval over which we're integrating, we have a vertical asymptote. We have some place where the function is not defined. Okay, any questions about that? Okay, so let's look at another one here. Let's suppose that we have, okay, so let's look at this one. Let's suppose that we've got negative 1 to 2, something like this, and we've got 1 over x cubed, let's say. Let's just look at this one. Okay, now, we've got an interval here, negative 1 to 2. And you'll notice that everything's fine in this interval except at 0. So we're concerned when we look at this interval and we notice that this interval from negative 1 to 2 contains 0. When we notice that, that tells us, okay, we've got on our hands an improper integral. Things are about to get real. So what we do is we identify where you have the problem. The problem child is at x equals 0. So here's what we need to do. We need to go from negative 1 to 0, 1 over x cubed. Okay. And then I want to go from 0 to 2, 1 over x cubed. Okay. So that's what we do. That's how we set that up. So we break it apart at the part where we have something that's going to give us problems. And that problem is 0. Now, after I do that, now I've got 2 integrals on my hands and I have to deal with those. So here's what I'm going to do. I'm going to say I'm going to take the limit as b goes to 0 from the left this time. Negative 1 to b, 1 over x cubed. See that? Because now on this interval from negative 1 to 2, if we're going to go from negative, if we're looking at negative 1 to b, the way we approach b is from the left. That's why it's a one-sided limit. Now over here, we have the limit as b, well, I tell you what, let me, I've still got this 0 here. The limit as a goes to 0 from the right. All right, so what we would have is we would have a 2, 1 over x cubed. Now, so that's the way we divide up this integral. And then we've got 2 of these to worry about. Okay. Now, if you look at this, so here's what we have. We have the limit as b goes to 0 from the left. Now, the antiderivative of 1 over x cubed, well, that's like x to negative 3, and the antiderivative would be negative 3 plus 1, 1 over it, x to the negative 3 plus 1. So it looks like what we have is we have negative 1/2 x to the negative 2, and we're going from negative 1 to b. Okay, so that's that first integral. Now, I'm going to do this one over here. It's going to be the same antiderivative. We're going to take the limit as a goes to 0 from the right, and it's going to be negative 1/2 x to the negative 2, going from a to 2. Whoops, a to 2. Okay, a to 2, like that. Now, all we have to do is go ahead and evaluate it. So we have our 2 integrals. And let's see what this first one is. I have the limit as b goes to 0 from the left, and that's going to be negative 1/2 Yeah, and here is b to the second, right? I'm just putting in a b, okay? Minus a negative 1/2 times negative 1 squared, right? So there's that one. Now, let me go over here and do this one. I'm gonna take negative 1 over 2 times 2 squared minus the limit as a goes to 0 from the right, negative 1 over 2 times a squared. Okay, any questions about that? Everybody see what I did? Just plugging in. Okay, now, when we do this, before we try to do any arithmetic, we notice that, yeah, these numbers right here are fine. Those are just numbers. But look at this. This one right here. As b goes to 0, this thing blows up, doesn't it? And so does this one. Both of them do. So what we're going to say is, we're going to say this diverges. Because as soon as any part of this diverges, the whole thing diverges. Okay. So there we're finished. Any questions about that? Okay, so let's look at another one then. Let's look at the integral from 0 to infinity, dx over the square root of x, x plus 1. Okay, so this will be a good one. Okay. So this kind of builds on everything we've done so far. There's some problems in this one, right? What do you see as a problem right away in this interval? Huh? Well, but I'm going from 0 to infinity. 0, right? 0 is a problem right away. Okay? So we've got to deal with that. Plus, we've got this situation where we're going to infinity. So it looks like this improper integral is not just the one type, it's both types that we've looked at so far. So what we have to do is we just have to calm down a little bit and realize, okay, I've got a little bit of work to do. But I know how this game is played. What I'm going to need to do is I'm going to need to deal with the 0 part of this. So what I can do is I can just pick a number. And I think what I'll do is I'll pick this number. I'm going to say, okay, I'm going to go from 0 to 1. And I've got dx over the square root of x, x plus 1. Okay? I've got that one. So that's how I'm going to deal with the 0. I'm going to put that 0 at the end point where I can take a limit. Now, then I'm going to pick it up at 1 and go to infinity, dx over the square root of x, x plus 1. Okay. Now, I've taken a problem that had two concerns. I'm dividing by 0 on the one hand in this interval, and then I'm going to infinity. And now I've given each one of those problems its own interval. Okay, so look, here's what I want to do then. I want to take this first one. I'm going to let a go to 0 from the right. Like that. And then this other one, it's going to be a limit as well. The limit as b goes to infinity. Okay. And it's going to be dx over the square root of x, x plus 1. Oh, and there's a b up there, isn't there? Okay, like that. Now, what we've done is we've looked at two types of integral. Though the improper integral where you're going to infinity, infinity is in the bounds, and then we had another one where an asymptote, a vertical asymptote is in the interval. Well, this one has both of those. And this is how we deal with an integral like that. We just break it apart. Okay? Now, so our job just simplifies to working both of these integrals. Now, so what we've got to do is we have to say, okay, well, that's all well and good, but honestly, I don't even know how to evaluate that. I don't even know how to find the antiderivative. I mean, we might have something like this, and we just don't know what to do with it. So now we have to step back and say, okay, well, how do I even differentiate this one right here? Well, what do you think? Well, I wouldn't really go partial fractions. What I want to do is I want to try to make it as simple as I possibly can. You could multiply the bottom through. Now notice this. This is one of the things that you might consider. You might consider let u equal the square root of x. Because the radicals bother us. Yeah. And then maybe I could have u squared equals x. That seems like it might be going someplace. And then 2u du equals dx. Now, let's just see how that works. We've got, up top, we've got 2u du. And on the bottom, we've got, what do we have? We have u, and then x is equal to u squared. Ah, look at that. That's working out kind of nicely because look, that cancels. Ah, look at this thing. Now, this integral doesn't seem so tough anymore. It seems like we own this one. I don't think there's any hope for this integral at this point. Okay? Because look at what this is. This is 2 arctan square root of x. And I'll leave off the plus c. We understand there's a plus c. Okay? But we just need to know what the antiderivative is. And we're going to be plugging it into some bounds so we don't have to worry about the plus c right now. Okay? So there is our antiderivative. Yes, sir. Yeah, both of those. Both of the antiderivative works for here and here, right? I mean, it's the same integrand. Well, now what I'm going to do is I've got to go back and work each one of these problems. I mean, I've got to address each integral with that antiderivative. But now, dig what I have now. Let me rewrite this first one. What I've got is the limit as a goes to 0 from the right of 2 arctan square root of x. And this is going from, what was it, a to 1. And then we've got this one, the limit as b goes to infinity of 2 arctan square root of x from 1 to b. So this problem keeps getting simpler and simpler as we make progress. You know, we found the antiderivative, and now we're ready to just go ahead and see what this turns out to be. We've got 2 arctan of 1. Okay, arctan of 1 is pi over 4, isn't it? Yeah. Okay, so it looks like what we've got is 2 times pi over 4. Okay, minus 2. Now, as a goes to 0, what is arctan? Arctan, it's going to be 0, isn't it? Yeah, there you go. So there's what we have for that first one. Y'all see that? Because arctan of 0 is 0. Yeah. Now, okay, so let's look at this other one. What is 2 arctan? What is, as b goes to infinity, what is arctan? Yeah, pi over 2. So it looks like this is 2 times pi over 2. minus, what is arctan of 1? Yeah, we had talked about that a minute ago. Right? Okay, so there we have it. There's our answer. Ah, it does converge, right? Yeah, that thing converges. It looks like we've got, oh, look at this. This is going to be pi over 2 plus, yeah, pi minus pi over 2. Is this just going to be pi? Ah, that's lovely. We didn't see that coming. Such a nice, elegant answer. Pi. Yeah, pi. Okay, any questions about that? So what I've shown you here is just the technique. How do you set these up? We've got when you have infinity in your bounds, when you have a vertical asymptote in your bounds, and when you have a combo. So you just have to look at each integral and make a decision. Okay, how can I rewrite this using a limit? Okay, any questions?